Welcome back, ladies and gentlemen. This is the second video for 8-6A, which is covering the law of sines. This video is going to cover how to find the area of a triangle, which in junior high you always do the same way, but here in high school we don't necessarily always know the height of the triangle, so we need some alternative methods. So this is the first of those two alternative methods, which is based on the law of sines, hence why it is in the law of sines section. You see, you're actually able to find the area of any triangle if you know the length of any two sides and the included angle, which means if you know side, angle, side information, you can find the area of the triangle. Now, this does take a little bit of abstract algebra to explain, so I'm going to do the best that I can. Now, in junior high, you are told that the area of any triangle is 1/2 base times height. Now, in junior high, the base is always this horizontal side, and the height is always that vertical line through B. Now, that's wonderful if you have it, but in high school, we don't always have an altitude to one side. Sometimes all we've got is two sides or three sides in one angle. So we have to have some alternative methods for finding it. So what we're going to do here is we're going to do some trigonometry on triangle ABC. You'll notice that A, B, and C are the side lengths, just like they were for the law of sines explanation in the last video. H is the altitude from line segment AC through point B. So in theory, that could be any of the three altitudes of this triangle. I only have one of them drawn. Now what we're going to do here is we're going to name the point where that height intersects AC. We're going to name it point D. And the reason we're going to do that is because that splits triangle ABC, which could again be any triangle, into a pair of right triangles. And we're going to look at triangle BDC first. Now in that triangle, we know that the hypotenuse, which would be opposite angle D, which is the right angle, is A. And we know that H is the length of BD. So what we can do is we can look at angle C, which means that H is our opposite and A is our hypotenuse, which means that the sine of angle C, which is opposite over hypotenuse, must be equal to H over A. Now, none of us are big fans of fractions, so what I am going to do is I'm going to multiply both sides of the equation by A to clear that fraction, giving me that H is equal to A times the sine of angle C. Now, if we go back to the original area equation, which we said area of any triangle is 1/2 base times height, the way this triangle is drawn, B is the length of the base and H is the height of the triangle. Well, if we don't know H, that's not a big deal because we know algebra. In algebra, if H is equal to A times the sine of C, it can be substituted into any equation for H. So that would be 1/2 A times B times the sine of angle C, which is an alternative equation for the area of the triangle, the big triangle ABC, based on knowing two side lengths, A and B, and the included angle for A and B, which is angle C. Now, we could just as easily have done that from the perspective of triangle ABD. So here's that triangle, ABD. Okay, and again, we know that the hypotenuse of that triangle is side length little c, and the height, H, is still one of the side lengths. So now we're going to look at angle A. Well, for angle A, H is opposite, and the C is the hypotenuse. So the sine of angle A is opposite over hypotenuse, which means that the sine of angle A is H over C. Same argument as before, we're going to solve for H by multiplying each side by C, which is going to give us that H is C times the sine of angle A. Now, again, that means that if we take our original area equation, 1/2 base times height, and we realize that the height is written as C sine A, that means we can substitute C sine A in for H, which would give us another equation, 1/2 BC times the sine of angle A, which again is two side lengths, B and C, and the included angle A. Now it is a little bit of a stretch, but I'm hoping that you're willing to accept that I could have just as easily done this with one of the other altitudes and angle B, and make you realize that there are three area equations for a triangle when we are given side angle side information. They are, the area of the triangle could be 1/2 AB times the sine of angle C. It could be 1/2 BC times the sine of angle A. Or it could be, and I did not show this one, but I could have, AC times the sine of angle B. 1/2 AC times the sine of angle B. Now all three of those equations are really the same equation. It just depends on which two sides and angle we know. Now I'm also going to use these very quickly to prove the law of sines algebraically. This is where the law of sines comes from, because all three of those area equations are finding the area of the same triangle, triangle ABC, which means that all three of these expressions, they are all equal. So let's take these to a new page. We could write that 1/2 AB times the sine of angle C is equal to 1/2 BC times the sine of angle A is equal to 1/2 AC times the sine of angle B. These are all expressions for the area of triangle ABC. Then, if we divide all three of these equations by 1/2 ABC, well, the 1/2s will cancel. In the first fraction, A and B will cancel. In the second fraction, B and C will cancel. And in the third fraction, A and C will cancel, which leaves us with sine of C is to C, as sine of A is to A, as sine of B is to B. That is algebraically equivalent to what we've been using for the law of sines. So this proves algebraically that the law of sines would work for any triangle. All right, but that's just, again, we like to prove theorems as they come up. So back over to our notes, we've got these area equations, we're going to use them. So here we're told to find the area of each triangle shown, and we're supposed to round our answer to the nearest hundredth if necessary. Now again, look at what you are given here. You are given two sides and an included angle, the angle in between them. Now the angle that we're given is angle C. So technically, the equation we would be using is 1/2 little a little b times the sine of angle C. But the letters are unimportant. They're variables. They could be changed. It wouldn't make any difference at all. We do 1/2 times the product of the two given sides times the sine of the included angle. So the area of the triangle is 1/2 times 8 times 9 times the sine of 104 degrees. And we feed that to our calculator. So 1/2 times 8 times 9 times the sine of 104 degrees. And we get that the area of the triangle is approximately 34.930. Again, we're looking at that 0 because we're told to round to the nearest hundredth. That would be rounding down or leaving the 3 alone to get 34.93 square centimeters. Remember that area is always units squared. Okay, next problem. Again, we are given two side lengths and the included angle. So the area of any triangle is equal to 1/2 the product of the two side lengths, B and C, and the sine of the angle in between them, which in this case is angle A. So the area of this triangle is 1/2 times 18 times 22 times the sine of 31 degrees. And into the calculator it goes. That would be 101.977. That 7 that is the third digit will make us round the second digit up and give us 101.98, and my units are square meters. Okay, next two examples, again, same deal. Oh my God, they didn't give us a picture. That doesn't matter. If you look at what they gave you, if you want to draw a picture, you can. Okay, draw quickly, it doesn't matter. Okay, you're given a 25-degree angle for angle C. You're told the side opposite little a is 4 feet. The side opposite little b is 7 feet. So again, you are given two side lengths and the included angle. So the area of the triangle is the 1/2, the product of those two side lengths, A and B, times the sine of angle C, the included angle. So that's 1/2 times 4 times 7 times the sine of 25 degrees. Feed that into your calculator, and you get 5.916, which would round up to 5.92, and my units would be square feet. Okay, final problem. Again, you can draw a picture, but you shouldn't need to. You should realize pretty quickly that we've got little b is 10 inches, little c is 20 inches, and we have been given that angle A is 138 degrees. That is side angle side information. So the angle area of the triangle is 1/2 b times c times the sine of 138 degrees. I'm sorry, angle A. So we plug in what we know. That would be 1/2 times 10 times 20 times the sine of 138 degrees. And we feed it into our calculator, which spits out 66.913, meaning we would leave the 1 alone or round down to get 66.91 square inches. Okay, that does it for section 8.6a over the law of sines. Thank you very much for your time and attention.